Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy, and I am Jeetendra Dixit. So before we start, let me check sound and whether I'm live or not. Yeah, now I can see, yes, I'm live, and sound is also okay, good. All right, so here's my profile. I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for last 11 years. And also, hi Raghav, good evening, good evening. Actually, there was some error. I was trying for last 10 minutes. All right, so before we begin, let me tell you about the Plus subscription and Iconic subscription. So if you are preparing for IIT-JEE, then you can have two types of subscription. One is Plus, another is Iconic. In Plus subscription, you get access to daily live classes of all the educators who are teaching on Unacademy Plus, and you can watch their live sessions. You can join their courses, and there's no limit. I mean, you can choose educators of your choice. Okay, you can follow educators of your choice. No, no, no. Now there won't be any break. Means which kind of break? I mean, the break which we took in for last 3 days. That kind of break. That kind of break. We are giving Fab and May attempt. All right. Because do you have a choice that you need to give only two attempts? You can't give Fab, March, April, and May all four. I mean, you can give all four, right? And on the courses which I'm talking about are well structured. That you can see the plans. You can see the schedule of all the upcoming lectures in well advance. All right, of all the educators you're following. And that's what I'm asking. You can give all four. So why? Okay. So if February goes well, then you can plan May only. Otherwise, you can give in March also and April also. What's the problem? It will increase your chances of improvement always. Even you can focus on the first and last mainly, but you should also appear for March and April attempts because the number of attempts you increase and the probability of you getting good rank will increase. It's a simple funda. Yeah, but giving exam is not a problem. I mean, the same day you keep preparing for JEE Advanced because the syllabus is same. The type of problems you are choosing are of advanced level, and the meanwhile you can go and write the exam. In fact, in that way, if you feel free, like okay, I'm just giving this attempt with this much of preparation is already done, right? In February. So when you're preparing for advanced, you're not preparing anything different. You are preparing the same thing, right? So you can go and write the exam. Hello. Yeah, we'll talk about this later, okay? We'll do this conversation about April and March attempts. Hello, Gia. Good evening. All right, guys. So these are the. Let me quickly finish this subscriptions and then we'll begin the session. How are you, Gia? The IIT-JEE subscription charges you can see for Plus. You can see in the list, left hand side the price list is given, and right hand side the prices given are after 10% discount. So for 1 month it is 7,000, for 3 months it is 17,500, and 6 months 28,000. For 12 and 24 months it is 38,500 and 56,000. All right. For Iconic subscription also you can see for Iconic subscriptions you get all the benefits of Plus, and apart from that I'm also good. All the benefits of Plus, and you get a personal coach who will guide you throughout your preparation for top exams. Your test analysis will be done in a personalized manner. Personalized feedback will be given to you, improving your time management to improve your time management and exam approach. Your study planner will be customized. Okay, and these are the subscription charges. You can subscribe for 6 months, 12 and 24 months. And the given prices you'll get 10% discount as well using the same code. Use that code JEET1. All right, that is my referral code. This is an Academy's learning app which you can download from Play Store, and after downloading it you can start your special free classes, free And to attend those, watch those free classes, you need to use the same code, JEET1. You can use that code. Hello, Akshay. You also came? Good. Okay, so where did we finish last time? Circles, right? We were doing tangents. So I'll start with a question. Let's see if you guys remember that. Wait a minute. Just a moment. I forgot to put the card on. Oh. All right, now let's begin. Yeah, Akshay. I know, I remember you, Bhavesh. Why do you have a different name on YouTube, huh? You have two profiles. Okay, let's start with this question. Find the value or values of k if 3x plus 4y plus k is equal to 0 touches x square plus y square is equal to 4. Okay, this circle. The simple question. Bhavesh, see you on the doubt class today. Okay, I have a doubt class on Unacademy today at 9 p.m. Okay, so I'll see you there. So find it quickly. So I want to use two methods for this. The first method is the condition which we have learned. What was the condition? If the line y is equal to mx, if line y is equal to mx plus c touches x square plus y square is equal to r square, then condition was c square is equal to a square 1 plus m square. All right, or you should write r square 1 plus m square. Okay, c square is equal to r square. A means radius. Good evening, Debjyoti. So we can use this condition because this is also a circle of x square plus y square is equal to r square type. This you can apply only for standard circles, okay? Not for shifted circle. I mean only for those circles which have centers at 0, 0. Otherwise you can't apply this condition. I hope you are getting it, huh? So if I apply this condition, you can find the, so first of all, you need to write the equation of this line in y is equal to mx plus c form. So if you write that, so 4y is equal to minus 3x minus k. And if you divide by 4, meanwhile, you keep plus minutes 10. Okay, so divided by 4 divided by 4, okay? Now you can compare. So what is the c? What is the value of c? That is k square, k by 4. So k square by 16. What is the value of r? Radius. So radius r is you can see in the circle. It is 2. R square is 4. So 4 and 1 plus m square. What is m? M is 3 by 4. So it is 9 by 16. Okay. I hope you are getting it. plus minus 5 by 2 plus minus 10. Okay, let's see. So k square is equal to, if you take LCM, it is 4 into 25. Okay, so yes, it is 10 plus minus of 10. So k is coming out to be plus minus 10. This is method number one. This is method number one. I hope you are getting it. But this method is only applicable for standard circles. The second method which we are going to do is applicable for any circle. Okay, you just need to write the center. So if a line touches a circle, I would suggest the second method, because it involves the same calculation. You don't need to remember anything. So if you have a line which touches a circle, then no need to remember this condition of tangency. What you can do is you drop a perpendicular from the center upon this line, 3x plus 4y plus k is equal to 0, and that should be equal to, that perpendicular should be equal to radius. So if this is OP, this OP should be equal to radius. Okay, so if you need to write OP, then the perpendicular distance of 0 0 from this line. So this center can be anything, right? In this case it is 0 comma 0. So it is 0 plus r divided by under root of 3 square plus 4 square. Okay, and that is equal to, this is k, I'm sorry, that is equal to r, radius. So radius is equal to 2. Okay, so if you see, solve it, mod of k is equal to, this is 2 into 5 is 10, and then you can see k is equal to plus minus of 10. Okay, so it's very simple. There's another method 3, which this Raghav is talking about. Solve this line with the circle. Okay, and it will be a quadratic in, either make a quadratic in x or quadratic in y. Okay, either make a quadratic in x or quadratic in y, and that quadratic should have repeated roots. If you are making a quadratic in x, then it should have a repeated root, because if line cuts the conic, cuts the circle or parabola, so this third method is basically applicable for all or any other curve. So third method is more generalized. Second method is recommended for circles. Okay, first method is recommended for all standard curves, because for every, listen to this point carefully. The first method is for standard curves, because we know this condition of tangency for all these standard curves. So that means circle with center 0, parabola with vertex 0 0, ellipse with center 0 0, hyperbola with center 0 0. Okay, so the curves which have their center at 0 0, and in case of parabola, vertex at 0 0, and they are symmetric about both the coordinate axis, they are standard curves. Okay, so for the standard curves, we will be knowing the condition of tangency. So you can always apply the condition of tangency for standard curves. Okay, so as of now, you know only one standard curve, that is circle with center 0 0. Okay, later we will know the parabola with its standard parabola, and then standard ellipse, and then standard hyperbola also. And similarly, the condition we have brought, we have proved for this circle, the same kind of condition will get standard parabola, same kind of condition will get standard ellipse, same kind of condition will get standard hyperbola. Okay, but those conditions will be applicable for only standard curves. If curve is shifted, like the circle is shifted with its center at some h comma k, then this first method is not applicable. Then circle has second method, but the other curves will not have this second method, like distance from center upon tangent is equal to radius, because this is a property of circle only. So this second method will be applicable only for circles, and the third method, which is Raghav was talking about, discriminant 0. Yes, Debajyoti, today night. So third method I'm talking about is solving the line with the circle. So let me tell you the third method also, how to solve this line with circle. So in third method, what we do is method 3. This is a general method. Okay, you can apply this method for any 2-degree curve. 2 degree means all the curves which you are going to study in coordinate geometry. Okay, all those curves. M1 को भूल जाओ ना sir, because doesn't work in case of shifted circle. More likely we will get shifted only. You need to remember this condition, y square c square is equal to a square 1 plus m square. Although you don't need to apply this, okay, but you need to remember this condition. Samjhe, Raghav, you can't forget this, c square is equal to a square 1 plus m square. You need to remember this, okay. But yes, you can apply condition number 2, method number 2 for circles. if line is given. And the method number 3 is also you can apply. So method number 3 is, because method number 3 is valid for any curve, okay. So method number 3 is you need to write like you need to solve these two curves, okay, curve number 1 and curve number 2. And how do we solve it? Like we are going to make a quadratic in x. So you need to replace y. How to replace y? Just put the value of y in this curve from this line. So you can see y can be written as, we have written it here, right? Already written it here. Just put in this equation. So it is going to be 3x plus k divided by 4 the whole square is equal to 4, okay. Now multiply it by 16, so it is going to be 16x square plus 3x plus k the whole square is equal to 64, okay. Now it will be a quadratic, so I'm not solving it completely. Now it is a quadratic in x, you can see this, right? You can see it is basically 25 of x square, and then it is going to be 6kx, and I think it is going to be yeah, minus minus 64, yeah, minus 64 and plus k square is equal to 0. So you need to put the discriminant of this is equal to 0 because line is touching the curve. So it should have repeated roots, okay, not distinct roots. You can see when line cuts, you'll get two different points, so two different coordinates of x and two different coordinates of y. But if line touches the circle, that means you'll get repeated values of x. All right. So I hope all three methods are clear to all of you. This third method is applicable for any curve. Guys, got it? Third method is like making a quadratic in x and then putting the discriminant is equal to 0. If you put discriminant less than 0, that means line passes outside the curve. If you put discriminant more than 0, that means line cuts the curve at two distinct points. So you further gets two more conditions, okay? If line cuts the curve and line passes outside the circle using this third method. In fact, using second method also you can answer whether line cuts the circle. If OP is less than R, that means line cuts the circle, and if OP is more than R, line passes outside the circle. Alright, so I hope it is clear now. I'll try to extend as much as possible. Let's see. Alright, so now the next thing arises is this. I'm giving you one question, okay? I wanted to give this question in the last session, but I ended early, so let's do this question now. If find the equation of tangent. So very simple, no calculation, okay? Less calculation in this. So find the equation of tangents to x minus 1 the whole square plus y minus 2 the whole square is equal to 4 square 4, okay, from the point 3 comma 8. I know this point is outside the circle. You can always check whether point is outside the circle or on the circle or whatever. I'll tell you the conditions for that, whether point is outside, inside, or on the circle. On the circle, you know, but outside, inside, I'll tell you. Just tell me the slopes, okay? Just tell me the slopes or equations of tangents, basically. Now you know all the methods, huh? So in this also we'll discuss two methods, okay? One method is for circles only, especially for circles, and the second method is a general method, okay? Or maybe I'll tell you which method is general method. First, you guys tell me what is the answer and which method you have used. You can use the equation of tangent for shifted circle of slope m. Just assume the slope m and write that shifted equation of tangent for the circle, and then you know the procedure after that. 0 and 4 by 3. This GI is getting 0 and 4 by 3. All right, let's start. So if I let slope of tangent is m. So first method is basically a general method which you can apply for any curve. I mean, it's similar procedure, which is the writing the equation of tangent in slope form, okay, for shifted curves or standard curves. So we already know the equation of tangent of slope m for standard curve as well as shifted curve, because if you know the equation of tangent for a standard curve, then you can write it for shifted curve also, just by replacing y by y minus k and x by x minus h, whatever you can I mean see in the equation of circle. In equation of circle, y is become y has become y minus 2 and x has become x minus 1. So similarly in the equation of tangent also, put y is equal to y minus 2, m times of x is equal to x minus 1, plus minus, you can take plus or minus, anyways doesn't matter because ultimately you need to square. So a under root of 1 plus m square. All right, a means radius. So in this case, what is the radius, by the way? In this case, you can see radius is 2. All right, so r under root of, so 2 under root of 1 plus m square. All right, this is the equation of tangent. One slope is 9, other is 2. 9 and 2 are not correct. 9 and 2 are not correct, and 0 and 4 by 3 are also not correct. One slope is certainly wrong. Okay. Acha, now you have you followed this method? Tell me, have you guys followed this method? Gia and Raghav, writing the equation in slope form. Tell me fast. Have you solved? Yeah, okay. Now after that, what you need to do, because this tangent is passing through, you are drawing a tangent from an external point. So you can see two tangents will always be there. Two tangents will be there. That means you should get two equations. All right. You should get two equations and two slopes, obviously. Not you should not write two tangents of same slopes. That is not possible from a point. Now put 3 comma 8 in this equation, because this tangent is passing through 3 comma 8. Okay, you have written the equation of this tangent in slope form, assuming the slope m. Now tangent is passing through 3 comma 8. So put in this equation, it is going to be 8 minus 2 is equal to m times of 3 minus 1 plus minus of 2 under root of 1 plus m square. All right, now this is 6 minus 2m the whole square is equal to, it is going to be 4 into 1 plus m square. I've done the squaring by taking this term to left hand side. Okay. Now 4 you can cancel by taking 2 common from this. So 4 it is 3 minus m the whole square is equal to 1 plus m square. Is that okay? Check your calculation. That funda we are going to use in second method, okay, Raghav. So I'll check your calculation error also because you have done some error. After that, you can see m square minus 6m plus 9. This is going to be the equation 1 plus m square. And you can see m square will get cancelled. Do you guys remember if m square get cancelled in any quadratic in slope? Whenever you're writing a equation in slope form, see, I'll repeat, I'll start from the beginning. Whenever you are finding the equation of tangents from an external point to any conic, whether it is parabola, ellipse, hyperbola, or circle, okay, you should get two values of slope, okay. So that means whenever you are solving using first method or second method or third method or fourth method, okay, that means you're making an equation in m basically because you need to find m only, right? So it should become a quadratic, but sometimes it will become a linear only. M square will get cancelled, okay? If m square is getting cancelled, that means what? This is my question. You are getting only one value of m. So that value is actually 9, 3, you will cancel 3 by 2. 3 by 2 is the value. So you're getting only one value of m and the other value is not there. You can't put this value and plus minus because plus minus is not going to give you two tangents. That will give you two parallel tangents and one of tangent is your answer. Where's the other tangent? One is not y-axis, it is parallel to y-axis, Raghav. That means whenever it is not a quadratic, it becomes a linear. The equation of slope becomes a linear equation. M square gets cancelled. That means your other slope is not defined. Other slope is not defined in which case? In the case of vertical tangent. In the case of vertical tangent, right? That means the other tangent passing through 3, 8 is vertical. The other tangent passing through 3, 8 is vertical. This tangent, the second one is actually vertical. So what is the equation of this vertical line passing through 3, 8? What is the equation of this tangent passing through 3, 8? Remember this case. I'm telling you this thing again and again. One more time I have told you that whenever m square gets cancelled and you are supposed to find two values of m, that means one m is not defined. So the other line is vertical. We have done one such case in straight lines also. And now this is a very popular case in case of finding tangents from an external point. Sometimes it becomes vertical and you can easily see it actually. You can easily figure it out. If you just look at the diagram, you can always figure it out that the other tangent is vertical. Just have a look at this diagram. The center is 1, 2 and radius is 2. So if you go 2 units horizontally, what is this point? Because vertical tangent will touch this circle at this particular point. So this, if you move horizontally, this point is going to be 3, 3, 2, right? X coordinate will increase by 2 units and Y coordinate will remain same. So this 3, 2 is the horizontal end. If you draw this horizontal diameter, then this is one of the end and this is the other end. So vertical tangent will be either at this point or at this point, right? So if you know the coordinates of horizontal diameter of a circle, there's always a horizontal diameter of a circle. In any circle, there's a horizontal diameter. So vertical tangents will always be at the end points of horizontal diameter. I mean diameter which is parallel to x-axis. You can see this coordinate is 3, 2 and this coordinate is 3, 8. Okay, so you can see x coordinates are same. So if you draw this line vertical, it is going to pass through 3, 8. This line is x is equal to 3 line. All right, guys, got it? X is equal to 3 line. You have not written the right equation of line. Three x minus 2y plus, okay, that is one of the tangent. What is the other tangent? X is equal to 3. Okay, you guys have not written the equation of this tangent. X is equal to 3 is the equation of vertical tangent. Now is it clear? Now is it clear? हाँ, दूसरे वाले की is okay. Okay, so now method number 2. Method number 2 is a general method which is applicable for any No, sorry. Method number 2 is only for circles, okay? Method 1 was general method. But this method is we are going to follow in parabola, ellipse, and hyperbola also. Method number 1. Now, method number 2 is especially for circles. In this case, you don't need to remember anything. I mean, the equation of tangent. In case you forget this equation of tangent in slope form, then you can use this second method. You can just assume the equation of line passing through 3, 8, okay? You can take your 3, 8 here, okay? You can just assume the equation of slope of this line and then write the equation of this line. Again we are assuming the slope, so equation of tangent is y minus 8 is equal to m times of x minus 3. That means I have already used this point P, okay? I'm already writing an equation of line passing through P and of slope m. Now our aim is to find that this line is touching this circle, okay? So what to do if this line is touching the circle? Then drop a perpendicular from center of this circle upon this line, okay, OP, and that should be equal to radius. So we need to do this. OP is equal to R, and this kind of condition is only valid in circle, okay, in no other curve. I mean, in other curves you don't have any such condition, not similar to this even. That means this method is only applicable for circles. So OP, distance from center, which is 1 comma 2. So put 1 comma 2 in this equation. So you'll get m times of 1 minus 3 minus y minus 8 is 2 minus 8 divided by under root of 1 plus m square, okay? That is equal to radius. So what is the radius, by the way? So radius is what? Radius is what? 2, okay? 2. Minus 2m is plus 2m, okay, and this is minus of plus, so plus, and finally minus 2m, let it be minus 2m, and this is plus 6, so plus 6, okay, yeah, is equal to 2 times of 1 plus under root of 1 plus m square. So you can see you have got the same equation, right? After squaring it is going to be same. 2m minus 6 the whole square is equal to 4 times of 1 plus m square, okay? We have reached to this equation now. This one, see, this is step, same. So you'll get m is equal to 3 by 2 only. The other value is not going to, you're not going to get the other value. Got it? So second method, G are clear? In this method, you don't need to remember any equation. Just OP is equal to R. All right, now let's move to another part then. So we are done with, so if a line is given, it is touching a circle, then we need to find some parameters, apply the condition of tangency. So we have done one question based on that and finding the equation of tangents from an external point. Now, suppose a curve is given, okay, I'm telling you some terms first of all. So S, suppose, is this x square plus ax square plus by. I'm writing the 2-degree general equation. That means the terms which I'm going to write now are valid for any 2-degree curves. That means parabola, circle, ellipse, and hyperbola, okay? So ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to c, okay, plus c, not c is equal to 0, plus c. This is S. That means S is equal to 0 will be equation of curve, equation of conic. It may be a pair of straight lines, it might be a circle, it might be a parabola, it might be a hyperbola, depending on the condition, depending on the values of A, B, H, G, F, and C. All right. I hope this point is clear. So I'm taking this expression, name of this expression as S, okay? So this is S is equal to this. And S is equal to 0 represents the equation of conic. No, not T is equal to 0 in that case. No. I'll tell you where to use T is equal to 0. Now the second term is with respect to a point x1, y1. Suppose a point is given x1, y1. So with respect to this point x1, y1, we have two terms, okay, for this given conic, for this given equation of curve. One is S1, that means if you put this point in this expression given above, this expression, the value you get is called S1, that is ax1 square plus by1 square plus 2hx1y1 plus 2gx1 plus 2fy1 plus c. All right. So that means, like, if this is a conic, okay, and if you take this point x1 y1 on the curve, so of course s1 will be 0. I mean, this point will satisfy the equation because you have written all the terms to one side and right hand side it is 0. So any point on this curve must satisfy the equation. All right. So because right hand side 0, so left hand side must be 0 if point lies on the curve. If point does not lie on the curve, then this value will not be 0. This value will be either positive or negative. So, okay. So like for closed curve, like circle, a point inside the circle gives this value positive. Sorry, negative. And outside the circle, points will give this value as positive value. I'll explain that later. Just understand that this is a value for some point. If you put a point, coordinates of a point in the equation of the curve, the value you get is called S1. The only condition is that you need to write all the terms. Like suppose this is a line. This is the equation: x square plus y square minus 2x is equal to 4. Okay. Uh, so what will be S? S is going to be x square plus y square minus 2x minus 4. Remember that for circle, you will always take S with coefficient of x square and y square positive. Somebody can take it like 4 minus 4 plus 2x minus x square minus y square is equal to 0. You can write like this, and then you can take this is equal to s. No. Okay. In case of circles, and in case of circle, always take with positive coefficients of x square and y square. Is that okay? I mean, you need to take all the terms to right hand side. Then it should be like this: x square plus y square minus 2x minus 4. Okay. If with respect to point set x1 y1, what is your s1? Your s1 is x1 square plus y1 square minus 2x1 minus 4. All right. I hope it is clear now. Which is not an equation of circle. I'm not talking about circle. Here I'm talking about any curve. Okay. Here I'm talking about any curve. S1 is the value which you get when you put a point in the equation of the curve. Curve means cone, any conic. All right. Gia, is it okay? Have you understood S1? What is S1? Just put the coordinates of the point in the equation. That's it. All right. Another term is t. Okay. T. So what is this t? T is, if you replace in any equation, if you replace x square by x1, obviously we're writing with respect to x1, y1, y square by y1, and 2xy by xy1 plus yx1, and 2x x plus x1, and 2y as y plus y1. Only once. Okay. Once you need to do it. It should not be like x square is replaced by x1 and then again x is replaced by. No, you need to do this process only once. Okay. So you have only 5 types of terms in any equation: x square, y square, 2xy, 2x, and 2y. And you need to do it only in 2-degree curves. Okay. Not in line. So if you write t, then t in this equation is going to be axx1 plus byy1 plus hxy1 plus yx1 plus g 2x can be written as x plus x1 and f into y plus y1 and plus c. All right. This expression is called t. All right. This expression is called t. So these these 3 terms, in fact, s, s1 and t are very important because we are going to write a lot of equations in terms of s, s1 and t. We are going to write a lot of equations in terms of s, s1 and t. All right. And some of the equations will be valid for all the conics. There will be some chords, okay, some lines with respect to a curve whose equation is going to be same for all the conics. Is that okay? All right. The first equation which we are going to learn in terms of these terms is equation of tangent at a given point. Okay. Okay. Before that, let me also tell you one thing. Position of a point. Position of a point with respect. I'm telling you two forms. Position of a point with respect to a circle. Okay. Equation of circle is S is equal to x square. Circle S is equal to 0. Okay. Where S is x square plus y square plus 2gx plus 2fy plus c is equal plus c. Okay. This is our S. You can see coefficient of x square and coefficient of y square in S is 1. Okay. Positive. So if a point is inside, you can easily see that suppose this is the point P x1 y1. Okay. This is the point. And this is the center. Center is minus g comma minus f, right? So if you write OP, so OP is going to be under root of x1 plus g, distance formula, whole square plus y1 plus f the whole square, all right? And now you compare it with radius. If OP is greater than radius, okay, that means OP square is greater than radius if point is outside, right? First case. So you can see OP square is x1 plus g the whole square plus y1 plus f the whole square is equal to r square is what? G square plus f square minus c. Then point is outside, right? You can see if you open it, it will be x1 square plus y1 square plus 2gx1 plus 2fy1, and then g square plus f square will get cancelled from left hand side and right hand side. And c you can take to left hand side, so plus c is greater than 0. This is what? Do you know what is this? What is this? This is S1. That means instead of doing this much of calculation, okay, now we have got a result, and because this expression is a familiar expression, S1. So S1 more than 0. That means if I put this point in this expression and I just check the sign, if this sign is positive, that means point is outside. Similarly, if S1 is negative, this is point for outside point is outside. If S1 is less than 0, that means point x1 y1 is inside, because you know OP square will be less than R square, so this inequality sign will be reversed, right? So it will come out to be S1 less than 0. And if S1 is equal to 0, that means point is on the circle. This is quite obvious, right? Got it? So this is one of the formula where we have got this S1. So similarly, there are many formulae in which this S1 is going to appear, this T is going to appear. Now I'm going to tell you one formula where this T will appear. Okay, got it now? So with respect to circle, now we know that S1 is positive. This is not true for any curve, okay? That S1 is negative for the if point is inside, if S1 is positive for point is outside, okay? Not for any other curve. It is only for circle. It is only for circle that if S1 is less than 0, point is inside, no matter it is a standard circle or a general circle, okay? Coefficient of x square and y square should be positive. That is the only condition, okay? Coefficient of x square and y square should be positive. In the previous slide, I was telling you this thing. See, if this is the equation of a circle, then somebody should not take this as S1, okay? That will be wrong. That will reverse your sign, because you are taking coefficient of x square and coefficient of y square minus 1. So in this case, S1 will be actually positive for points inside the circle, and S1 will be negative for the points outside the circle, okay? Because you have written the S1 in a different manner. I hope you're getting at this point, huh? Raghav, not for all the parabolas, there might be some difference. A standard parabola is a different thing. So I'll tell you one method after that. Got it? Got it? Got this point? Guys? Jia got it? All right. Okay, then let's move on. One more formula, length of tangent. Length of tangent from x1, y1 to circle x square plus y square plus 2gx plus 2fy plus c is equal to 0. All right. So we need to write the equation of length of tangent. Formula for length of tangent. What is the formula, Raghav? Suppose this is the point. Obviously, point is outside because if point is inside, you can't draw a tangent. And if point is outside, you can draw two tangents which will be of equal length, right? These two tangents will be of equal length. Same. OP is equal to OQ. So OP is equal to OQ is equal to, what is the formula, Raghav? This is the root of S1, okay? This is the root of S1. Just put the point in the equation of, okay, you know S1, right? This is your S, then S1 is x1 is square plus y1 is square plus 2gx1 plus 2fy1 plus c. The same calculation is same. You know how to find OP. You have just got it, right? OP. Okay, I should take this point A, okay, A. So you know how to take AO and you know OP and you can apply Pythagoras in this, right? So this AP, okay. I need to change this point as well. The proving is very simple. AP is under root of OA square minus OP square, right? So basically it is OA square minus R square. And you can see in previous slide, this is OA square minus R square only. This is OA square and this is R square, right? So this was nothing but OA square minus R square. Are you guys getting it? This is nothing but OA square minus R square, which is S1, right? शाम में बात कर रहे थे प्रकाश कुमार राय. शाम मतलब कौन सी शाम? हाँ, so this is under root of S1, all right? Okay, so this is under root of S1. You got the formula for tangent, length of tangent. That means just put the coordinates of the point in the equation of the circle and take the square root of that. That will give you length of tangent. Have I told you the power of a point? Power of a point. Power of a point, power of a point, with respect to a circle is OP square minus R square, right? I've told you this. So OP square minus R square is always S1. So power of point is this, S1. Now, in this case, let me write OA square here. So power of a point A, I told you this, power of a point A is OA square minus R square, which is S1. That means power of a point is positive when point is outside, and power of a point is negative when point is inside, and power of a point is 0 when point is on the circle. So do you get this? Power of a point is S1. Geometrical formula is this OA square minus R square, distance of that point from center, square of that minus radius square, alright? PA into PB is another form, okay? This is the geometrical formula, OA square minus R square, okay? Have you got this point? All right. Now suppose there's a circle. Now I am making a figure in which we'll learn a lot of terms. If I draw a tangent from an external point, if I draw a tangent from an external point, two tangents, say this is the point P and these are points of contact A and B. This is center of the circle O, not origin. It can be minus G minus F. If I join these points with the center, then this is 90 degree and this is also 90 degree, all right. If I join A and B, this line, this yellow line is called chord of contacts. This is a chord by joining points of contact. So in any curve, if it is a parabola and if you draw two tangents from an external points, okay, two tangents you can draw, and you join these points of contact, this line is called chord of contact, okay, chord of contact. Is that okay? I win count. This line is called chord of contact. So we'll come to equation of this line later. First, we are trying to understand a few other points. Chord of contact. No, 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 no. I'm asking something else. So first thing you need to tell me. First thing, see, we need. I'm telling you what we need. This equation of circle is given. Equation of circle is given. Equation of circle is S1 is equal to 0, where S1 is, sorry, S is equal to 0. S is equal to 0, where S is equal to x square plus y square plus 2gx plus 2fy plus c. This P point is given, say x1, y1, okay? This P point is given x1, y1. So first of all, I need, I'll tell you what I need. Area. First of all, I need area of triangle PAB. That means area bounded by this area bounded by tangents and their chord of contact. Are you understanding this? Area of this triangle. This. I hope it is clear, right? So a lot of questions you can frame on this diagram. Second, I need area of triangle AOB. All right. Third, you know, I need area of triangle AOP or PAO. I should say PAO. And then you can write the area of the quadrilateral, that is double of this. So I'm just leaving that point. Fourth, I need this angle. Say this angle is 2 theta. Angle between the tangents. That is 2 theta. Fifth, okay, length of tangent we have already done. Length of tangent we have already done. PO we already know. Radius is okay. So last we can find is length of chord of contact. That means AB. So you can solve these questions in any order, okay? Whatever you can find first, you can find it, okay? It should not be, I mean, you don't need to solve it in this particular order. You can find like chord of you want to find the equation length of chord AB in the beginning, you can do that. So whatever you result you can find easily, you find it and tell me. You need to write your answer in these terms. Let me tell you. You can use radius r because we know the formula of radius. So radius is basically under root of g square plus f square minus c. So you can use r for your answers. Okay. You can use this term s1. Okay. So whenever you are getting this x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So you need to write all the answer in terms of r and s1 only. All right. R and S1. I hope I am clear. All right. What is this h square plus k square minus a square raised to 3 by 2? That means you're writing a s1 raised to 3 by 2. I think r s1 raised to 3 by 2 upon h square plus k square. You need to write your answer, Raga. You need to write your answer in terms of s1 and r. H and K are point of contact? No, we don't know point of contact. We don't know the coordinates of point of contact. We only know the point P, coordinates of point P and the equation of circle. Area of PAO is very simple, right? 1 by 2 R into root of, yes, yes. This is the simplest thing. G has started with the simplest thing. This is root of S1 and this is R. This is a right angle triangle, right? So she started with this triangle. She started with this right angle triangle whose height and base are already known, right? You can see height and base. This is the height, radius, and this is the base, root of S1. So area of this triangle PAO is equal to 1 by 2 height into base. So root S1, right? Good, fine. You can also find this angle easily, right? I think you can find this angle easily. Theta. This is half of the angle, right? Yeah. Yeah, that's right. That's right. Okay, try Raghav, try to find the other answers, okay? I think you know this formula. Solve it geometrically. Let's take this point PQ. Let's take this point Q, okay? Midpoint of AB. This is midpoint of AB. Q. Can you tell me the theta? This result you can find in terms of tan inverse. You can use this right angle triangle. This one. This is P, this is O, this is A, right? This is R and this is root S1. This is theta. So tan theta is R upon root S1, right? Tan theta is equal to R upon root S1. So you can write theta is equal to tan inverse of this. Is that okay? So 2 theta is going to be 2 times of tan inverse of r upon root s1. Is that all right? Now try to find the length of chord of contact. First, you should find the length of chord of contact. Now that will be very useful to find the first and second. If you find the length of chord of contact AB in terms of R and S1, of course. You can also use, shall I tell you the answer? Are you guys solving it? All right, all right. All right, now let me solve it. So to find AB, you can see this diagram. In this diagram only, diagram I used to find theta. This is AQ, half of AB, right? So POA. In this, PO we know, right? What is PO, by the way? You know what is PO? Distance of point from center. PO was, no, PO was not S1. PA is S1. PO, you can write S1, see, PO cos theta is root S1. Okay, let me use this diagram. This is better actually. Should not use this one. Simply use this diagram. Because anyways we need to use theta. So if this angle is theta, this length is root S1, right? So you can use this as right angle. So AQ can be written as root S1 sine theta, right? Is that okay? So AB is equal to 2 times of root S1 sine theta. Now you know, because you know tan theta, so you can write sine theta and cos theta also. So is that okay? This is 2 root S1. I am writing sine theta, okay? So because tan theta is R upon root S1, so sine theta is going to be R upon under root of. Now this is your perpendicular, this is your base. So hypotenuse is going to be r square plus s1, right? Under root of r square plus s1. Is that okay? This is your sine theta. I'll write sine theta and cos theta also because it is useful to write sine theta and cos theta. So sine theta is going to be, shall I write it here? Sine theta is going to be r upon under root of r square plus s1, and cos theta. What is cos theta? Cos theta is going to be under root of s1 upon under root of r square plus s1. Okay. I hope it is clear now. All right. Okay. You have written, Raghav, you have written 2s1r. 2s1r upon root of. So it is 2 root s1r actually, right? Have you understood? It is 2 root s1r or 2r root s1. You forgot to put root on s1. And denominator it is alright. And it is not s1 square, r square plus s1, not s1 square. Raghav, are you able to figure out your mistakes in your formula? Root and in denominator it is not s1 square, it is only s1. Now area of triangle POA. Now area of triangle PAB. Okay. So for PAB you can use this formula. Which formula? You know, in any triangle, if two sides are known, A, B, and angle between the sides is known, then area of the triangle is 1 by 2 AB sine alpha. Do you remember this formula? You can use this formula here. First of all, I am erasing all these things above. Tan theta I'll keep. I'm creating some space here. Okay guys, so do you know this formula 1 by 2 AB sine theta? If this triangle is given, and in this triangle this is A, this is B, and this is alpha, then area of the triangle is 1 by 2 AB sine alpha, right? So in this triangle APB, this angle is 2 theta. This side is root s1. This side is root s1. Are you guys getting it now? So area is 1 by 2 of area. Area is equal to 1 by 2 of root s1 into root s1 into sine 2 theta. Right? So sine 2 theta, I am writing 2 sine theta cos theta because we know sine theta cos theta. Okay. So 2 sine theta cos theta. Alright. So 2 and 2 will get cancelled. This is S1. Now put the value of sine theta. This is sine theta. This is cos theta. So sine theta cos theta is R into root S1 and divided by root of R square plus S1, root of R square plus S1. So it is R square plus S1. Okay. So finally you can see final formula is, I am writing it here. It is R S1 raised to 3 by 2 divided by R square plus S1. Okay. Is that all right? What याद किया तो बाकी भूल जाऊंगा. What do you mean by that, Raghav? No, it's okay. That's why I am solving all these things, so that in case if you forget, you can find it easily using geometry. You can always write r, you can always write s1, you can always easily find theta, you can easily find all these distances. So that's why I'm solving all these cases. In case you forget, you can apply this formula. I mean, you can use this geometry. Gia, is that okay? Are you getting these formulae? All right. So one last formula, AOB. I mean, one last area we are going to find. This. What is this angle? Can you guys tell me? What is this angle? This angle is going to be pi minus 2 theta, right? So area of this triangle is area. This triangle is like this. This AOB. A. You just see how many questions I'm framing based on this diagram. Still, you have a lot of. I mean, I have some more questions based on this diagram. So you know this angle now, pi minus, this is radius, this is radius. So if you apply the area of this area, this is 1 by 2 r into sine of pi minus 2 theta is sine 2 theta only. So that is sine 2 theta. Okay. So in place of r1 you are going to get, in place of s1 now you are getting r square. All right. So again, if I solve it further, what is the result? Now see what is the result. Just wait for a minute. It is now, okay, 2 and 2 will get cancelled if you open sine 2 theta. It is r square sine theta into cos theta. So again put sine theta cos theta. That is r upon r into root s1 upon r square plus s1. That's similar. Now it is r cube root s1. I'm not suggesting to remember all these formulae. I am suggesting to remember the geometry. All right, r square plus s1. But in case if you want to remember any formula, you can remember it. This first one generally the students remember. This angle I don't recommend to remember. You can always prove it easily. This you can prove easily. This you can prove easily. Length of chord also you can find easily. So this first one is the formula which you can remember. The first formula. The first formula is the one which you can remember. The rest you can find easily. Yeah, in that practice session, I have solved a few points of geometry, like 3-4 questions, not more than that. It's a short session. It was a premiere, yeah. Hey guys, got it? I want to ask one more question. I've solved all these questions, okay? Yes, geometry is useful. So if you don't know any geometry of geometry which I have used in those questions is very good actually. I have taken 2 sessions, huh? Yeah, 2 sessions. Just go through that session, and there will be 7-8 questions in total in all 2 lectures. So check the geometry of all the questions, geometry in all the questions. Okay, we should know that. Actually, one of the question is from JEE Main only. One of the question was there in JEE Main this year in January's exam. All right. Okay, I want to ask one more question based on this diagram. So I'll do that in the next page. The next page, the question is, in the previous question only, I'll make the diagram again. So in this circle, you have drawn 2 tangents. Now you guys need to write this answer. This was A point, this was B point, this was P point, and this was O, okay? So now I am asking you to write, okay, S was given, equation of circle was given, S was x square plus y square plus 2gx plus 2fy plus c is equal to 0, and this point P is given x1, y1, okay, this is given. The same question. This is given x1, y1. Now write circumcircle. Circumcircle of triangle PAB, okay? Write the equation of circumcircle of triangle PAB. Now this is the question. It's a very, very good question. You need to write the circumcircle of this triangle. PAB. Equation of circumcircle of this triangle. PAB. Now tell me the answer of this. Okay. So this is the last question I'm asking based on this diagram. Are you guys getting it? Yes, this is the right thing. So I think I haven't told you the diametric form of a circle. So basically OP will be the diameter of the circle, and diametric form is this is the diameter. First let me tell you the diametric form of a circle. If you know the diametric end points of a circle, any diameter, there are infinite diameters of a circle. X1, Y1, and X2, Y2 are the diametric end points. This is AB is the diameter. Okay, suppose AB is the diameter of a circle, then equation of the circle with diameter AB can be written as x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Okay, this is called diametric form. Diametric form of a circle. All right, this is diameter. Is that okay? Have you got it? Basically, you have a proof of this. This point is on a circle. You need to write a locus of this point, which diameter subtends right angle. So how do you get this equation? By writing the slopes m1, m2. So if you multiply this m1, m2 is equal to -1, you'll get this equation. Okay. What is m1? m1 is y minus y1 upon x minus x1. What is m2? y minus y2 upon x minus x2. Okay. Yes, m1 is y minus y1 upon x minus x1, and m2 is y minus y2 upon x minus x2 is equal to -1. So you cross multiply and bring all the terms, you'll get this equation. Okay, so it's a simple proof of diametric form. So if you know the diametric endpoints of a circle, you can use this equation. Like in this case, OP will be the diameter. Why OP will be the diameter? Because you can see this PAOB quadrilateral PAOB is cyclic quadrilateral, right? Why it is cyclic quadrilateral? Because you can see this is 90 degree and this is also 90 degree. Okay, if sum of in any quadrilateral is like this. In any quadrilateral, if sum of opposite angles is 180 degree, it is cyclic quadrilateral. So any circle which pass through 3 points out of these four will pass through the fourth point also. So that circle is going to pass through this point as well, right? PO. So because circle will pass through P and O will be the diametric endpoints. And why diametric? Because this angle is 90 degree, right? First of all, they are cyclic, and OP will be the diameter because angle PAO is 90 degree. So as angle PAO is 90 degree, this implies that PO is diameter. I hope this point is clear. We know O is minus G minus F. We know P, so we know diametric endpoints. We can write the circumcircle. So circle is x minus x1 into x plus g plus y minus y1 into y plus f is equal to 0. All right. Ptolemy's theorem. Why do you want to apply Ptolemy's theorem in this? There's no use of this theorem, Ptolemy's theorem in this. You can write it simply using diametric form. Yeah, for cyclic quadrilaterals you have this theorem, Ptolemy's theorem, but to write the equation you don't need it. Is this all right? Can you see this? It's a very beautiful question. They can ask the equation of circumcircle of AOB or PAB or PAO. Any of the triangle. Out of these 4 points, you can form any triangle. They will have same circumcircle. Equation of circumcircle will be same. So you can ask the circumcircle of AOB triangle or PAB triangle or PAO triangle. All triangles will have same circumcircle whose diametric endpoints are x1, y1 and minus g minus f. All right. All right. So is this point okay, guys? All right. So now we will continue tomorrow. Okay. Raghav. Tomorrow I'll try to tomorrow, but I have one more session at 9 o'clock for practice of straight lines, mainly pair of straight lines basically, and one of this session as well. Actually no, because I have another session at 9 o'clock and I have to do dinner and all. We'll try to finish it. I mean, we'll try to continue tomorrow and maybe day after tomorrow also. I'll finish in 2-3 lectures, okay? Theory part at least. And then we'll discuss questions in these special classes, all right? So in next session, I'll tell you the equation of tangent at the point which lies on the curve. So we have done tangents from an external point and tangents of a given slope, but we haven't done tangent at a given point on the curve. Okay, that is very easy, very easy actually. So we'll do it tomorrow. For advanced, what? I have finished parabola, please. Then premier practice session, sir. I've finished parabola, please. I'm trying to make some videos for this locus problems based on locus. Okay, that I'm going to continue. That I'll continue on this next channel, JEE Quest. So The next three sessions are going to be on based on locus equation of locus, how to find equation of locus from the basic. So first you'll see the questions of straight lines, and then I'll bring some questions of circles, and then slowly I'll bring questions of any conic. So that way I'm going to finish all the questions of conics first, and then after that I'll discuss parabola, ellipse, and hyperbola. Okay. Circles I'll finish in 2-3 sessions, next 2-3 sessions, theory part. All right, chalo, then take care. Okay. Jia, you also can see those problems of circles, which I've discussed on JEE Quest. Two small sessions are there. Total 7-8 questions will be there. So just quickly watch those 7-8 questions. They have some geometry involved in that. Correct? So you can watch those sessions. All right, chalo, take care. Bye bye. Good night. All right. All right. All right. All right. All right. Okay. Thank you, everyone. Take care. Bye bye.